Okay, well then I'm just gonna start. I am videotaping today's lesson because if people are at home, I want them to be able to see what we're doing, and I've already got a few calls, but if you sit yourself down, I'll see if I can even see you. I'm not even gonna be able to, I think I'm just gonna maybe see a part of the back of you, but that's it. Yep, fine, wonderful, don't even see you. I think maybe I see your hand, but that's it. Thanks for putting away your phone. Welcome again. For full disclosure, I am taping this session of our class, and that is so that my students that are at home ill will be able to participate in today's lesson if I send it to them. So I'm going to email this or put it on my calendar so that everybody can kind of be with us where we need to be. It's important. At this time, everybody should have either your paper notebook open or your electronic notebook, and you're going to be writing down our daily question. Our daily question is based directly of yesterday. It's a reflection of what we went over yesterday in class. Yesterday in class, I also handed out a vocabulary sheet, and I know that some people didn't get one. Were you able to print it out? Do you need one? Is there anybody else that would like a paper copy of the vocabulary sheet? Everybody got what they wanted. Fabulous. You'll notice on your table you've got marshmallows. Don't eat them. They are not a snack. We are going to be using them in an investigation we're going to do today. And you also have a periodic table. That is going to be what we are going to be using in our investigation today as well. Our question today, why do stars shine? If you don't immediately know the answer to this, where can you get information to help you answer it? Notes from yesterday. Yesterday we had a delightful story. Jacob, could you remind us, what was our story about yesterday?
Nuclear fusion.
Nuclear fusion. Give me a little bit more about that. What was the story kind of like about? What happened? Anyone? Anyone? Anyone?
The story or
The story. No, story. What happened? You have these two people. Yep.
Two people that were exactly alike. They hated each other, but everyone pressured them into
They were
being
repulsed by each other. That's right.
like you two would be perfect for each other. So
Right.
they ended up falling in love and being inseparable. They had a daughter who ended up jumping off a cliff onto Earth.
Okay, right. So their daughter from their union was Thena the photon. All right, and so that is right about nuclear fusion. So stars produce their own light through a process called, thank you, let's go ahead and make a complete sentence. So stars, my pen is not doing well lately. Oh, come on, little buddy. It's so great when like technology works. Okay, so stars produce their own light through a process called nuclear fusion. Great. A process called nuclear fusion. Am I going too fast? Adam, how would you describe nuclear fusion? What's fusion?
When two things come into one.
Nice, when two things come into one. Okay. Why is it called nuclear? What are the two things that we're trying to force together?
Hydrogen and
What about hydrogen though? Why is it nuclear? An atom, what's at the atom's center? The center of an atom is not Carmel, it's called the, oh wow. What?
Nucleus?
Yeah, it's the nucleus. And so this is called nuclear fusion because we are fusing two nucleus together, two nuclei together. That's why it's called nuclear fusion. So during nuclear fusion, comma, the nucleus of one atom is fused, which is just a word for combined or put together, with the nucleus of another atom. I am going to draw a picture of this. My recommendation for those of you that have your electronic notebook, go and Google a picture of nuclear fusion and add that to your section. I'm going to just take a very simple, erase that, a very simple drawing based on what we did yesterday, where I'm going to use my hydrogen and my hydrogen. Those things are going to come together and they are going to form my new larger element called helium. You with me so far? Great. We still don't know why they have light though. So let's add that. During this process, what's released?
Energy.
Ah, that's right, phena the photon. During this process, a small amount of light energy, and I'm going to go ahead and in parentheses put photon, is released. And I'm going to show that in my drawing. That's my photon. So stars produce their own light through a process called nuclear fusion. That doesn't answer the question. That just names the process. Okay? So remember this the next time you take an exam. And I am putting together a form so that for those of you that failed the exam, you will have the opportunity to fill out this form, do some reflection, and then I will send you a code so that you can take another exam if you would like. But when you just say, right, oh, the answer is nuclear fusion, and you don't describe it, you don't really tell me what you understand nuclear fusion to be. Stars produce their own light through a process called nuclear fusion. During nuclear fusion, the nucleus of one atom is fused or combined with the nucleus of another atom. During this process, a small amount of light energy or a photon is released. And you have a picture. Amazing. Questions on that? Yep. Wonderful. Wunderbar. What we are going to do then is we are going to look a little bit more at stars and the nuclear fusion process in our investigation today, which is called fusion and the periodic table. I have given you a periodic table on your desk already. That periodic table is made possible. First of all, this is the latest and greatest version of the periodic table. The original periodic table did not look like this. There have been several what's called iterations. Caitlin, put your phone away. Several iterations of the periodic table. I cannot imagine that they would change it again in the future, but it is possible, I suppose. 100 years ago, they probably never thought their nuclear or periodic table would be changed. So we're going to be using this, studying what's happening in the stars. All of those elements on the periodic table were made possible through nuclear fusion. In the beginning of our universe, all we had was hydrogen and helium, our very first elements. If there never would have been stars created, all we would still have in the universe would be hydrogen and helium. That's it. Okay? Because all of the other elements have been created due to stars. Without stars, we don't have you. We don't have this bucket. We don't have these marshmallows. Okay? We don't have anything except hydrogen and helium. We are finished with our computers. If you could please close those, I would appreciate it. I am going to hand sanitize and then hand you out the other 2 copies of what you are going to need for our investigation. Please make sure that your name and your class period are listed on this sheet so that if you lose it, we know where it goes. If you are one of my students that has still not purchased a folder or a binder to keep your science materials in, please make sure that you get that done. My stress level goes up when I see students reach into their backpacks to pull out science material. That is not the best way to organize. So I have got a note that I have written on my hand, and I am going to try to remind myself to go to Walmart or Target and see if I can purchase a bunch of folders and see how many, I'm gonna see how much they are, and then how many I can afford, and I will have some folders for some people. So if you need that, I can give that to you. This is so good, so nice. Nice and organized. Oh, I'm so sorry, Liz. I apologize. Okay. All right, you can push your names and class period on here. You're so very welcome. And let's talk about fusion, or combining more than one thing together, and the periodic table. So it's supposed to be like 50 degrees out right now. Has anybody checked? It just looks beautiful. Yeah, check to see what the temperature is, if you wouldn't mind.
41 and cloudy.
Okay, well, she's got you on that one, man.
43 and cloudy.
43 and cloudy, so 41 and climbing. Isn't that nice? Hopefully we'll get up to 50 degrees. Everything found on our planet is made up of elements. You're made up of elements. Elements are produced or made in the cores, which are the centers of stars, by nuclear fusion. All stars start by fusing the element hydrogen, and they end up creating many heavier or more massive elements inside their cores or the center. Remember, mass is all about how much matter something is made of, okay? How much matter. So, we're going to use modeling today, and our marshmallows are going to help us model the fusion of elements. That's what we're going to be doing. Throughout its life, a star makes up new elements by fusing together atoms in its core. What does fuse mean?
Combined.
Okay, fuse means to combine. To combine two or more objects together. Fabulous. Stars are mostly made up of elements hydrogen and helium. But we're also going to be talking about atoms. So what is the difference between an atom and an element? What's the difference between an atom and an element? If I said, hey, give me the smallest amount of gold you can, atom, what would the size of that gold be?
What was the question?
I want the smallest amount of gold possible, and it's still gold. How small would you give me? I don't know, I'm asking Adam.
I don't know.
What do you think, Caden? It would be one single atom of gold. Anything smaller than that, and now I'm breaking it up into subparticles, and now it's just like a proton, an electron, a neutron, and it's no longer gold, okay? So an atom is the smallest particle or building block of a substance. The smallest particle, or you could call it a building block. Of a substance. And it's still that substance. So if I said, Adam, give me the smallest piece of gold you can, he'd be like, here's one single little atom of gold. And it would still be considered gold. An element then is a substance made up of all the same type of atoms. So a substance made up of all the same type of atom. If I said, give me a pound of gold, and I want it to be pure gold, well then, Caden would give me a pound of, I don't know how many atoms of gold that is. But they would all be the same, if it's element of gold. If it's silver, they all have to be the same atom, which is silver. Good? All right. So we're going to go ahead and look at our marshmallows. It says take one marshmallow or look at one marshmallow in the pile. If you don't want to touch it, you don't have to right now. It's just a marshmallow. I am the only one who touched them. I had hand sanitizer. I opened the bag. It's a fresh bag. So I want you to know that all of the items that we are talking about here have not been reused. So if nobody else has touched these, you are good.
So the marshmallows you safe to eat?
No, in science, very good. In science, you are not going to ever eat things in a science classroom.
Unless they're edible.
But unless your teacher specifically
I know,
says
I'm
you
kidding.
can, okay?
I'm kidding.
Because you don't want cross-contamination. It's not a good habit to get into. So, one marshmallow from the pile. Today this is going to represent one proton in our element model. So it's going to be a subatomic particle called a proton. Awesome. The number of protons an atom has in its nucleus, which is its center, determines what kind of element it is. So what I want you to do now is go to your periodic table and find hydrogen and circle it on your periodic table. I will go to my periodic table and look for it. And I see it up here. I'm going to circle that. That is going to be where hydrogen is. Fabulous. I believe then it says, number 4 says, based on the model that I've given you on the periodic table, the carbon model, which is located right here, see if you can find out how many protons hydrogen has. So let's go ahead and look at this model. I see that the letter is going to always be the chemical symbol for the element. The element's name, or the chemical's name, is going to be right in the middle. So I see H for hydrogen, and there's hydrogen. And the atomic number is always the number of protons in that one atom of that element. So carbon has 6. How many protons does one atom of hydrogen have? 1. So let's go ahead and fill that in our worksheet. So on number 4, where it says based on the model of carbon, find out how many protons are in one atom of the element hydrogen. 1 proton. Number 5 says that in our model, 1 marshmallow is going to represent 1 hydrogen atom. So if we have 1 marshmallow and hydrogen has only 1 proton, each proton or each marshmallow is going to represent 1 hydrogen atom. Now, it says take 2 protons or marshmallows out of the pile. This is going to represent the nucleus of 2 hydrogen atoms. Put your hands together with the protons or the marshmallows inside. So put 2 marshmallows inside of your hands. Today, our hands are going to model the core of a star. Temperatures are so hot and pressure is so great inside stars that the atoms are moving tremendously fast and crashing into one another. So I want you to crush those 2 proton marshmallows together in the palms of your hands. I've got my 2. I'm going to have heat. I'm going to have lots of pressure. And I'm going to force these 2 together. Crush them. I'm going to crush them. I crush you. I am fusing them. I am fusing them together. And this is what I have. Okay? So now, look at the periodic table. What new element did we just create that now has 2 protons in the nucleus? Because this is no longer hydrogen. With 2 protons, raise your hand, don't blurt at me. With 2 protons, what do we have now? We're going to go Liz on this one.
Helium.
We have helium now. So on the next page for mine, I don't know about yours, I'm going to write Helium. I have just created a model of a helium atom. Great. I want you to make me 2 more helium atoms. Out of what you have in front of you, you're going to then make 2 more of these. So this is my 1 helium atom. If I want to make another one, what do I have to do with those marshmallows? Take 2 more, squish them together. Crush, crush, pressure, force. There's another one. I'm going to take 2 more, force them together. Heat, pressure. And now I've got 3 helium atoms total, because it says, let's make 2 more helium atoms. So I should have 1, 2, 3 helium atoms now on my paper towel. Let's draw a picture of that process. We're going to go ahead and show hydrogen coming together with a hydrogen, and that is going to make a larger helium atom. On my 1 hydrogen, I'm going to write a 1 with a P, saying that it's got 1 proton. A 1 with a P, saying that this has 1 proton. I put 2 protons together, and my helium will now have 2 protons. Good? Yes, dear. Yes! You can go out that door, and I've unlocked it, so you can come back in that door too. Fabulous. We're now on 8. Are we good? Should I slow down?
No, we're fine.
You're fine. What does that mean? Good, good. I'm seeing good. Eye contact. Love it. Let's take those 3 new helium atoms that we created and let's fuse them all together in our model hands of our core. So I'm going to take all of these together and I'm going to squish them. I've got heat. I've got pressure. And I'm going to make a brand new element. Ah, there it is. Look how massive that element is. Using the periodic table, which new element have we created? I'll give everybody a chance to look for a minute, and then we'll go ahead and, Caitlin, I did see your hand first, so give everybody a chance to look. It's a little sticky, but I've got some sinks if you'd like to wash up. So what's our new element, Caitlin?
Carbon.
Which one?
Carbon.
Carbon. How did you know it was carbon?
Because 1 thing of helium has 2 protons in it, and so we have 6 protons total. 6 protons is carbon.
6 protons total. If we look at our periodic table and I find carbon, which is right here, I see that it has 6 protons, and so I know that this new element that I have created is in fact carbon. So I'm going to come back up here and I'm going to say my new element is carbon. I'm going to put the chemical formula for that, or the representation, a C, and the number of protons in its nucleus is 6. Fabulous. Now, could you please use the periodic table and look at what other elements could we fuse together to make carbon? Give me one example, Caden.
Lithium?
Okay, how many?
2.
So I'm going to say lithium plus a lithium is going to make a carbon. Because lithium has 3 protons, and so if you take a lithium and fuse it together with another lithium, you are going to get a carbon. Corey, give me another example from the periodic table. What would add up to number 6? Just look at the numbers and what adds up to 6. So lithium has 3. Well, see how he went 3? He said lithium plus lithium would give me a carbon. So if we have to have a total of 6, what else could I fuse together to make carbon? Well, what is beryllium? What's Be? How many number, or Be? It's at the top by hydrogen. How many?
4.
So how many extra would I need to add? 4 plus what equals 6?
Two.
So where do we see that's 2?
Helium.
Right, so a beryllium plus a helium would also make a carbon. So let's go ahead and add that. So we've got beryllium, which would be Be, plus a helium, which would be He, would also make a carbon. Sydney in the back. Give me an example.
Lithium, oh yeah,
You can do lithium, lithium plus what?
well, helium and hydrogen.
Okay, so we can go lithium, which has got 3, plus a helium, which has got 2, plus a hydrogen, which has got 1, and that also would make carbon. Jacob, give me one.
Could we just do 6 hydrogens?
Sure, thanks, Jacob. Hydrogen, plus hydrogen, plus hydrogen, oops. Back up. Plus hydrogen, plus hydrogen, plus hydrogen. 1, 2, 3, 4, 5, plus hydrogen equals carbon. Danny,
Could you do, I don't know if I'm gonna.
boron?
Boron and hydrogen?
Yeah, 1 boron, which is 5, plus 1 hydrogen, which is 1, would also give us a carbon. Is this rocket science?
No.
No.
No, it's nuclear fusion. So it kind of is. No, but this is not tough. I don't want you to ever look at a periodic table and be like, wow, I don't understand this at all. Yes, you do. This is what's happening in a periodic table. Okay, this is what's happening when we are trying to produce elements through nuclear fusion. Because then all we did here was we said if our new model that we created has 6 nucleus because we put together 3 helium atoms, what other formulas could we put together that would also create 6 protons? So we said lithium's got 3, lithium plus lithium would also give us a carbon. That's all we did here. All right, let's go ahead and look now at the periodic tables missing some. I pulled some out and put them here for you. Based on what we've learned in class today, where would we put zinc? Someone raise your hand, please. How about this? Claire, this one's for you. Claire, where would I put zinc in the periodic table?
After 29, before 31.
Okay, so she's saying that it goes between copper and gallium. And how did you know that?
Because they're numbered in order.
Yeah, and because if we look, and I said this on an exam, and I said, explain your reasoning, she would say copper has 29 protons, and gallium has 31 protons in its nucleus, and so zinc with 30 would go in between. Great! Quentin, where would iridium go?
Between 91 and 92, all the way down there.
I think you're talking about uranium.
Oh, which one did you say?
I said iridium, but I'm okay with uranium.
Oh.
So you're right, uranium would go right here between 91 and 93. And I don't know how to pronounce these, so I'm just gonna put, it's got 92 protons. I think that's nepotism, which, is that what it says? Is that what it says? Nephew? I apologize that these are, oh, is this a K? Yep. Is that a K or an X?
That's an H.
Is it an H? Well, I apologize for how fuzzy it came out. My bad. I'm terribly embarrassed about that. I apologize.
Looks like Neptunium.
Neptunium. And then this, last one, iridium, would go between number 76 and 78 because it has 77 protons. We have some very massive elements that have been created. These down here are actually man-made. So these elements were created in like an environment that is not natural. But this is your universe as you see it. These are the elements that make up the world and our universe around us. Notice right here I've got this row and this row. They come out of this location and this location. So right next to barium, which is 56, it says 57 through 71 go here. Well, rather than have those there, which would send this row all the way down here, It doesn't look nice and neat that way. So the scientists have said, we're just gonna go ahead and take this row out and put them right in here, and then 89 to 103, they're gonna put it right down here. So it's all nice and organized and neat. I just wanna let you know about that. Questions on that so far? God bless. Yep, can you what? You have something you wanna copy down? You have something up here that you want to copy down?
Yeah.
Okay. This is just for you to do, though, you do what you wanna do. You don't have to pick these, you can pick your own examples. Okay, let's go ahead and talk a note about energy. Nuclear fusion does not only generate new, heavier, or massive atoms. Each time two atoms lighter than iron fuse together, and we'll talk about why iron is such an important predictor here, the reaction releases energy. We're going to draw a picture of our two hydrogen atoms fusing together to make helium. This is very familiar. But this time, let's go ahead and show thing of the photon coming on out. So I've got my hydrogen and my hydrogen. We're going to fuse those two together. They're going to make our much larger, not much larger, but our larger helium. And then I'm going to send out my photon, my little packaged particle of light energy. You're just fast, like, we're just gonna start calling you Fina. All right. There's our energy that is being released. Back to why do stars shine? I'm gonna move on. Do you need to take a picture, or all you have to do here, honey, is we could have just done one example. That's fine. We're all good? All right. All right, so let's go ahead and organize the periodic table. You're going to follow my instruction as I demonstrate other ways that we organize and categorize elements of the universe in the periodic table. We're going to start small and slow because we are in 9th grade and we are not in an 11th grade chemistry class. So here's our periodic table of elements, and we're going to go ahead and create a key. We're going to separate this into metals, metalloids, and non-metals. So I'm going to start with metals. At the top of my periodic table, we're going to write metals, and we're going to put down some characteristics of metals. If you don't want to do it at the top of your table, if you want to do it along the side of your table, whatever you want. I'm doing mine at the top. We are going to need to highlight these different areas of metals, metalloids, and non-metals. And so I'm going to hand out to people that need them some, what are these called? Highlighters. So I've got my other highlighters that have been sanitized and are drying back there. These are now clean. If you have your own highlighters, use your own highlighter. If you don't, then what I'm going to do is I'm going to allow you to use these. When we are done, I will be by the door on the way out, and you'll be dropping them into this bucket that says used, and then I will be sanitizing them. Do you need them? Okay. Now remember, these are not like markers, right? Some of my students in past classes are like, I'm going to push down really, really hard. Do you need one? 3. You don't need to push down really, really hard on these, okay? They're not like, oh, I lost a top. They're not like crayons, right? So the harder you press, it's not like the better the color will be. You just need to kind of show some sort of color gradient on them. Wow. Oh, you don't need? Okay, then I will hand sanitize this one. I am down to my last. So we may have you use like your own pencil as one, and then one of my colors. And I don't have to be these colors. If you've got in your, book bag, any kind of colored pencils or markers of your own that you would like to use, definitely can go ahead and do that. You're good? Fabulous, yes,
We have, our shower curtain has the periodic table on it.
Oh,
and
that's
it's
so
separated into metals, non-metals, and,
Yes,
you know,
metals, non-metals, and metalloids.
metal.
Yes?
Yeah.
This worked out not bad. I will look to see if I have an orange, otherwise just shade with your pen, or just leave it white, okay?
Okay.
All right. Oh, I do. You need an orange, you said?
Yeah.
Okay, I'm going to throw this to you. I am not throwing it at you.
Okay.
Nice catch. Good. All right, my little ones, let's start with metals. Metals are characteristic, Metals are characterized by being able to conduct electricity. If anybody has ever been a small child and you stuck if you stuck a key or something metallic into a light socket, that's been bad. Has anybody ever done that? Good, don't do it again. How about that? No, not fun. All right. Metals are also very shiny. That's why we love them as humans. Like my ring, my gold ring is just lovely, shiny, shiny. My gold ring was able to be fashioned into that shape because metals are what's called malleable. M-A-L-L-E and then able. Malleable. You can bend them and they hold their shape and not break. Aluminum foil. It's aluminum, it's a metal that can be pounded down into a flat shape. Quentin, stop. All right, those are metals. So pick a color, I don't care what color you choose, and I'm going to show you where all of those are. So I'm going to use yellow for my metals. And you choose whatever you want. And metals are going to start with lithium and beryllium, and all down here are going to be, these are all metals. Those are all metals. Pick any color you want. Hydrogen is not a metal. And again, this does not have to be perfect. We're not pressing hard, we're not trying to, we're just identifying what they are. On the other side, look for number 13, that's aluminum. That is also a metal, and all down that column, gallium, indium, thallium, and I don't know how to say, lithium, that's all metals. Everything in between is metal. Zinc, copper, nickel, chromium, scandium, all of this. Metal, metal, metal.
Including like 1 through 7.
Absolutely, because that's included in this area also. So since those two rows were pulled out, those two rows also have to be included in that. These are also metal down here. Uranium is a form of metal. And if you discover an element, you get to name the element. So I'm seeing an element named curium. I'm guessing that was Madame Marie Curie. Do you notice any other metals that we might have forgotten? Liz?
Would tin be one?
Tin would be one. So not germanium, but tin at number 50, that needs to be marked as a metal. Below that, we have the metal lead. And then you're going to keep going down one more, 114, that also is metal. Bismuth is metal, that's 83. And then right down below that, and also 116. I'm gonna go up on my key and I'm just gonna highlight the word metal because this is a key. So if you could please on your key, highlight your word metal so that we know that all the metals are below. All right, again, doesn't have to be perfect. Let's go ahead and look at our non-metals. If metals conduct electricity, guess what non-metals don't do?
Don't conduct electricity.
That's right, they do not conduct electricity.
Hydrogen a non-metal?
Hmm?
Is hydrogen a non-metal?
Hydrogen is a non-metal. Non-metals are not shiny, they're dull. Non-metals are not malleable, they're what's called brittle, so they break very easily, they're brittle. I want to show you some examples of, or an example of a non-metal in my rock box. I've got some ores of non-metals. This is sulfur. Sulfur is an example of a non-metal. It's not shiny, you can't pound it into nice shapes like you can with gold, and it breaks really easily. It's a non-metal. Talcum, okay, talc. You can even use my fingernail and it like falls apart, okay? It's a non-metal. What is metal? This is an example of metal ore. What kind of metal is in here?
Oxidized copper?
Very good, it's copper. And so when copper does get oxidized, it turns greenish. And so copper is an example of a metal. This is also an example of a metal. You can see that it's shiny. This is called pyrite. This is an example of a metal.
Isn't pyrite called glucose?
It is, because a lot of people get tricked and they think that it's gold, but it's not. All right, so those are some examples. Let's go ahead and color in our non-metals. I am going to use a different color. I'm gonna use purple. I don't care what you use. That's not purple. Purple. There, I'm gonna use purple. You use whatever color you want to use. So my non-metals are going to be hydrogen. So as Caitlin said, all the gases are going to be non-metals. I'm gonna go helium, neon, these are all of our noble gases. They're very stable gases. Krypton, xenon, radon, all the way down. I'm also gonna go fluorine, oxygen, nitrogen, and carbon, but not boron.
Non-metal.
Phosphorus is a non-metal, so is sulfur and chlorine, which is another gas. Selenium and bromine are also non-metals.
I don't think silicone is it?
Oh, yeah.
Silicon is a metalloid, we're gonna get to that. Iodine is also a non-metal.
What is it? No.
On the exam, you're gonna be able to have this periodic table in front of you. go ahead and look at our metalloids. M-E-T-A-L for metal, and then another L, oid. Metalloid. A metalloid is not really a metal, it's not really a non-metal. It has the characteristics, it can have the characteristics of both metal and non-metal. So for here, we're just gonna say that it depends. Characteristics, it depends. And I'm gonna put in parentheses, can have characteristics.
Usually the very, very bottom row part of the middle.
Yes. Characteristic of both metal and non-metal. And that is whatever is left. So I'm gonna choose a different color. I will do green on mine. You choose whatever color you want. And we've got boron, silicon, germanium, arsenic, which is poison, antimony, and the like. Metalloids. I want to show you some pictures of what these metalloids and non-metals and metals look like. How are we doing on time, Gabe? Do I have 4 minutes?
I think so, yeah.
Yeah.
So I'm gonna move away from this. And, oh, here they are. Here are some pictures of what they look like. These are the metals that you're probably familiar with, right? Your copper, your tin. Steel is actually a combination of several things. Nickel, zinc, lead. Non-metals would be kind of like your sulfur that I showed you. These are different non-metals. Nitrogen is a non-metal. All your gases are going to be non-metals. And they're different metalloids. You've got boron, silicon. So notice how silicon is really shiny, but it's a really poor conductor of electricity. Arsenic, again, shiny, but brittle. Okay, so it looks like it should be something, but it doesn't have the other characteristics of it. So that's why they're metalloid. They're metal-like, but not really metal. I want to bring you to our weekly calendar. This is where we are right now. We did fusion and the periodic table. I do have a little video in here for some extra information on metals, non-metals, and metalloids. It's 7 minutes. I would recommend when you go over your science notes tonight, you watch it. If you have not done the homework from yesterday, I want to show you where that is again. It is right here underneath homework. You click on it and it brings you this. It says watch the video clip below, which is here, and then answer the following question. Here is the question that you're going to be giving me a short answer response to. If nuclear fusion is happening inside the sun, why isn't it blowing itself apart? So you're going to watch that 10 minutes. How many of you have watched it so far? It's a really awesome review of the story that we told yesterday. Okay, you can actually see that random walk. You can see Fina the Photon visiting all of her relatives. So get this done, please. It's important. I'm putting it into Power School after school today. Next week, when I am not with you, this week we're going to take notes on Wednesday together. And then next week, you're going to be doing what the B students are doing at home this week, which is watching Sisters of the Sun. There is a Google Doc. So as you're watching the video at home, you can go ahead and just type in the answers right here if you'd like. Or if you are somebody that wants a paper copy, I will tomorrow have some paper copies for you that you can put in your notebook if you prefer that. Okay, so you can do either one. That is for you next Wednesday. And this is where the video is. Okay, Sisters of the Sun. And it goes over what we are going to be learning in class. I wish that I could do them together, but I can't because I only get to see a couple of times a week. All right, so get your homework done, and then next week when we're together, we'll do. Well, I'll see you tomorrow. We're going to do notes tomorrow. Your marshmallows, please make sure that everything goes into that. Thank you. and then you're gonna throw it out on the way out, and you're gonna drop